Well, from the last video, I got down to having an equation with just two variables. Now, if I get one more with just two variables, I'll be able to solve for one of the two variables. How am I going to do that? Well, I have not used this piece of information about the point of inflection, and that's something I need to do. So what I'm going to do is I'm going to work with the second derivative because points of inflection are from the second derivative. I'm going to take the second derivative here, and I get 6ax plus 2b. Now, working with that, I'll be able to say, well, at 3, okay, so the point of inflection occurs when x is 3, I have 18a plus 2b. Well, we know that the second derivative would be equal to 0 at this value. So finally, I have something that I can work with where I can put this one and this one together and solve those simultaneously. So I will do that. I have negative 1 equals 16a plus 2b, and I have 0 equals 18a plus 2b. So we'll go ahead and change all of these to be negative, so they're easily solved. So I get negative 2a equals negative 1. So finally I get one of my values. A is 1/2. Now I'm not quite finished because I'm still supposed to find B, C, and D. And I should be able to do that pretty quickly. I'm trying not to lose people in this, but I'm going to try to get this done quickly. I'm going to find B by just plugging that back into one of these two equations. I'll just go ahead and plug it in right here. So I have negative 1 equals, I have half of 16 is 8 plus 2b. So if I move my 8 over, I get negative 9 equals 2b. And then b is equal to negative 9/2. So there's b. So I have two of my values. Now I can use those two values to help me figure out another one, maybe up here. So I'll plug it in. Oh, let's just do it right here, I guess. I've got negative 1 equals half of a would be 14, or half of 28 is 14, plus I'd have 6 times negative 9/2, which would be negative 54 over 2, which is negative 27, plus c. So that's going to allow me to solve for c. I end up getting, let's see, that's negative 13 plus c. Add 13 to both sides, I get c is 12. So there's my c value. And lastly, I'm going to be able to get d by going back to one of these very original equations, these first ones. So I'll see if I can squeeze that in here, right here. I get 2 equals half of 64. Half of 64 right there would be 32. Start over there. So I have 2 equals half of 64 is 32, plus I'd have negative 9/2 times 16. Well, that would end up giving me a negative 72, plus 12 times 4 is 48, and then I have plus d. Barely squeeze that in there. I don't know if you can see this. This is negative 40, and that would be 48, so it would give me 8 plus d equals 2. And so my d ends up being negative 6. Very long problem, but we did manage to get through it. Last example, the total cost, C, for ordering, storing X units is given by this. What order will produce a minimum cost? Minimums and maximums occur at the first derivative, so we're actually just going to find the derivative of this. I'll rewrite it first as 300,000 x to the negative first. So my first derivative would just simply be negative 300,000 x to the negative second. Well, I'll set this equal to 0. Move my 300,000 over x squared to the other side. Multiply or cross multiply, get 2x squared equals 300,000. Divide by 2, that gives me 150,000. And then I will square root the 150,000. Now we can check to make sure that is a minimum by looking at the first derivative. So the square root of 150,000 is approximately 387. So I could try maybe 400 into my first derivative, and I would find out that it is a positive there and then a negative here. So this does happen to be a minimum.